Hello guys, today I am going to explain about valid parenthesis program in LeetCode. Let's first understand what the problem is. They have given a string S containing just the characters. They have given just these three characters and determine if the input string is valid. Open bracket, we can say that input string is valid if these conditions are true. Open brackets must be closed by the same type of brackets. If this is the open type of bracket, and then it should be closed with these brackets, then we can say that the brackets are matching. Open brackets must close it in the correct order. Every closed bracket has a corresponding open bracket of the same type. So every closed bracket will be having the open bracket. So let's first check this for this example. These are the three kinds of brackets they have mentioned. So we can say that this is the valid parenthesis because this is opening and this is closing, and this is opening and this is closing. This is opening and this is closing. So these are the valid parentheses. Say for example, if it is like this is not a valid parenthesis because it is opening with parenthesis and closing with the flower bracket. So we can say that this is not a valid parenthesis. And say for example another, if it is initially the first bracket is a closing bracket, then we can say that it is not a valid parenthesis. These are the conditions we have. And how can we solve this problem is we can solve this problem using stack. Stack is nothing but a data structures. We can also call it as LIFO, which is nothing but last in first out. The structure of the stack will be like this. And the main functions of the stack is nothing but push, pop and peek. I'll briefly explain about what are those. And there is another which is called is empty, to check whether the stack is empty or not. Push is to add the elements into the stack, and pop is to remove the elements from the stack. But the stack works on the principle called LIFO, means nothing but whatever the element we are inserting in the last, that will be removed first. Coming to the approach of this problem, how can we solve this problem using stack is, whenever we find a opening brackets are nothing but these are the opening brackets. Whenever we find the opening brackets, we will push that into the stack, and whenever we find a closed bracket, we will pop it out. And when we have to pop is only when the stack is empty, then only we have to pop, otherwise it may lead to the underflow exception. Say for example, I'll take this and I'll show you how it will be done. Okay, this is okay. I will iterate this through the end of the string. And first what I am finding here is a opening bracket. So I have told that whenever we find a opening bracket, I will push it into the stack. So first I am finding a opening parenthesis, so I will push it into the stack. And whenever I am finding a closing bracket, The second one is the closing bracket. So now what I'll do is I will pop this on. I will check that first whether the stack is empty or not. The stack is not empty, so I will pop this out and I have to return the stack is empty or not. If this is only the condition, actually we are having some more symbol, so we will check with that. And next what we have is opening bracket. So whenever we find an opening bracket, we will add that to the stack. And next what we have is a closing bracket. So actually this is removed from the stack. Now only what we have is only this bracket. So now we have found that closed bracket. So what we have to check is we have to check whether the stack is empty or not. Stack is not empty, so I will pop this element and this will be also gone from the stack. And next what I found is the opening bracket. So whenever we find an opening bracket, what do you have to do? We have to push it into the stack. Next what we have is a closing bracket. Whenever we find a closing bracket, and we have to check that whether the stack is empty or not, and we have to check that this top element should be, means the peak element should be open, then only we will pop it out. This is the one condition which we have to remember. And now the stack is empty, so we have to return if these are the not condition, then we will return false. Actually, if all the brackets are matching properly, then the stack will be empty, so then it will return true. This is about the explanation of this, and the time complexity will be order of n, as we are iterating through the string. Is big of n, and space complexity also big of n, because we are using a stack data structure, right? So for that the time complexity is also big of n. This is the approach of this problem. I'll just write code for this. First I have to declare a stack, and I'll take a for each loop. And first thing is, whenever we find a opening bracket, we have to push it into the stack. So if the first character any one of the opening bracket, we are pushing that into the stack. The next condition what we can have is, if it is the closed bracket. So what are the other two conditions what we have to check is stack should be not empty, and the peak element means which the top element should be the open bracket, then only we can pop. This is for the parenthesis, and next other two brackets also we have to write the same condition. This should be closing, and what we can do is we can pop, and for the next one and the top element should be opening bracket, then only we can pop it. Else we can just return false. Finally what we can return is whether this return st dot is empty. I will just run it once and I'll see. Yeah, it is accepted, and I will submit and see. Yeah, it has accepted, guys. This is the solution for this. I hope you have understood this. Yeah, that's it, guys.